So here we're going to be looking at the shortest distance from a point to a line. So I've got an example question here, which is the shortest distance from a point to this straight line. Now, we don't have to draw a diagram every single time, but I've drawn a quick diagram here and we're going to have a look at what's happening. So here's my straight line. Here's my point, which is at P, which is 8, 4. And the shortest distance is always directly to the line in a straight line, and it always makes a 90-degree angle, which is really handy because it means that the gradient of this green line is always perpendicular or -1 over the reciprocal of the red line. So let's have a look at the steps we're going to do to find this distance here, the green distance. We're going to find the gradient of the line and then the gradient of the perpendicular. So we know the gradient of the line here is -2. Be careful of that -2 in there. So this gradient is -2. So let's just put this one here in red. This gradient is -2. And the green gradient is, and I'm going to call this one M for my line purposes, is -1 over the reciprocal, so it becomes a half. Once I've done that, I'm going to work out the equation of the perpendicular using the point that you've got here. Now I'm going to do it in y equals mx plus c form because I'm going to need that later. So let's do it up here. So I've got y equals a half of x plus c. The point on the line is 8, 4. And this is nice and simple because a half of 8 is 4, so c is 0. Don't have to add on anything. So now I've got the equation of my line, y equals a half of x. I've also got the equation of the line I started with, which is y equals 5 minus 2x. And I want to solve these two equations simultaneously. That's my next step. Solve the simultaneous equation of the two lines. Now, because I've written them both as y equals, if you use a calculator, a TI or your Casio, you'll be able to find the equation. I've used Desmos. So I've put in my two lines and they intersect here at 2, 1. You won't be able to use that if you're in a test or exam. You need to get used to using your calculator. So make sure you know how to draw two lines and find out where they intersect with a calculator. So 2, 1 is where they intersect. Let's come back in here, and this point here is now 2, 1. So finally, we've got 2 points, and we're going to find the direct distance between those 2 points. So 2, 1 and 8, 4, and we're going to use the distance formula. So 2, 1 to 8, 4, and this is just Pythagoras now. And hopefully you've done a few examples of using this. So the distance is going to be 2 and 8. That difference is 6. And 1 and 4, and that difference is 3. So I'm going to square those, and then I'm going to take the square root. So this is 36, and this is 9, so it's the square root of 45. And I go to my calculator, and the square root of 45 is 6.71.